So yeah, yeah, you know this one. You know, you do. Right. There we are, yeah.
I'm ready when you are. People have a quick drink of this.
Okay. Can we please start to take our seats? Ready for the final speaker? Hello? Can we take our seats now, please?
Sit down! Everybody sit down! Floor holder! Floor holder!
We're doing a really big siren, couldn't we?
That would definitely draw people's attention.
Get on the floor!
Can we take our seats, please? That one will be, yeah. Okay, so if you're not going to sit down, can you please stop talking? Right, okay. So, can we have a huge round of applause then for our final speaker of the evening?
Okay, thanks everybody for hanging in there for the duration of the evening. I'm Gaipo Jarni, or Gaipo, and I'm from SNEAK, which is short for So Now You Know. It is pronounced SNEAK as S-N-E-A-K. Just get these questions all the time. And I'm here to talk to you today about NPM dependencies and security. So I have a couple of slides to tee us off, and then most of the time would be in the terminal. So we all know NPM is awesome, right? NPM is ingrained into how we develop in Node. Hard to imagine how we develop in Node without NPM. And in return, NPM usage has quite exploded, right? Every time you need to revisit these numbers, because now it's like 240,000 packages, and they're downloaded 3.5 billion times a day. So definitely huge volumes, as kind of that growth of Node goes on. And within our applications, we see that a typical application uses many of those, right? Hundreds, thousands. I couldn't find sort of an accurate or believable stat, but it definitely is clear that in any application there's at least hundreds, if not thousands, of these dependencies. Which results in a situation that looks like this, where this is your application and this is your code. And from a productivity perspective, that's awesome. Because you didn't have to reinvent the wheel. You just had to sort of write your sort of core functionality in it. But from a security perspective, it's a little daunting because it means that all of that yellow, orangish circle is your attack surface. All of that is your exposure. But really, only the little purple section is the one you understand and you scrutinize. And each one of these dependencies is a security risk. It's a piece of code, and as code is, it has bugs. And some of these bugs are security bugs, also known as vulnerabilities. These are holes, these are gaps in those components. So this is sort of a threat, and it's a problem we need to deal with. It needs to be a part of how do we evolve, how we develop a node, and how do we kind of evolve. It's really not just a node or an NPM specific problem. So what I wanted to do is I want to switch over to the demo and just sort of show this as a real life example. Talk about an application, show the problems on it, talk a little bit about what those are, and then about what you can do about them. So, spoiler alert. Going into my browser, of course, this is a Node application. Of course, I have a to-do app. It's just sort of the express to-do application. I can go buy milk. Has a nice little feature where you say buy milk, bread, remind me in 2 hours. Beer, yeah, of course. I don't need reminders for that. So definitely sort of need to go off and do those sort of a nice application. So let's take a look. This is an application that I have here. If I do npm ls, just to see the dependencies on it, I have a bunch of them here. And what I'm going to do is I'm going to use a tool called Snick, which is our tool here somewhere. Open source, free. Well, the client is open source, it's a free service. And I will run Snick test here. Let me zoom up here. And I'll run Snick test. So before this, I've installed Snick via npm install -g Snick. So, right, maybe I'll bump it up a little bit here in the view just in case somebody doesn't see the bottom of the screen. So this is how you install it. I've already done that. And I run this, and you can see that it had 100 dependencies, a very modest number in today's world. And it found 8 vulnerabilities. So let's sort of dig into some of these vulnerabilities. I'll kind of start with the one at the bottom here. So I'm using this module called ST. If you're familiar with it, it was written by one of the NPM leads, Isaac, one of the Isaacs. It does a static file serving. If I go to my application, go in here, I've got this about page here that just sort of clarifies how important this website is. And it uses static resources for this about HTML. So I can go in here and I can do this. Now if I go into the information about this vulnerability and I click the info link, I'll get some information from Snake about what this is. And it'll tell me that ST in versions prior to 0.5 did not properly prevent folder traversal. So folder traversal or directory traversal is a pretty common problem where every time an attacker sees something like this, where it might be a static resource, they try to do this. They try to do sort of dot dot slash, try to sort of break out of the folder. Of course, yeah. It's not at all illegal to do it on somebody else's site. Or did I say not? Sorry. This is my site. So you can do that sort of dot dot slash. But ST does catch that. But what it doesn't catch is it doesn't catch this notion of %2e. So if I URL encoded the path, then it does it. Now if I do this over here and I say %2e, it would actually look like it caught it, but it's just because Chrome is translating those into dot dot. If I go back here and I do curl HTTP localhost 3001 static, so first I'm going to just get the HTML, so that works. And then if I go and I do dot dot slash, I'm just going to get redirected back into this sort of title to do page, so that just gets redirected me. But if I go and I put %2e, just going to copy that, then I get a different folder. And if I do that, and I'm just going to add dot dot slash as many times as I want, because it's just going to get to the bottom, and then it would sort of stay on the bottom. So all fine and good. Now I can show you this because on a Mac, the etc stability is actually not that sensitive, but on a Linux machine, this would be kind of the crown jewels. And you can use it for a bunch of things. Okay, so not great, right? This is one vulnerability we don't want to have. Came in through a dependency. Let's look at a couple of others. So the next one's a little bit more complex. Let's look at the first one here. It uses Mongoose. Who here knows Mongoose? Yeah, because again, kind of a pretty core tenet to it, very widely used as kind of the client really to Mongo to represent schemas and objects. So it again has a vulnerability. I'm going to click that. Get the information about the vulnerability, reported by Chalker, he's a good researcher in the node space. And it talks about a potential memory disclosure vulnerability that exists in Mongoose. So I'm not going to kind of get you through all this text, but just sort of explaining it. Mongoose uses or supports the ability of a field being of type buffer. Buffer is a very tricky element in Node. This is true for your code. It's true for the URL encoding piece for your code as well. Buffer has two constructors. It can take a string or it can take a number. If it takes a string, it allocates a buffer, sort of a string with that string in it, sort of whatever it is, 3 characters long. If it takes a number, then it allocates a buffer of that size. But what buffer doesn't do is initialize that memory. So in JavaScript, we're not used to dealing with memory. So C++ definitely kind of our bread and butter, but in JavaScript, not so much. And by not resetting that memory, it means now this buffer holds some memory that is potentially sensitive. It's whatever happens to be in memory in that section during that time. If you remember Heartbleed, which made all this sort of noise around OpenSSL, that was a memory leak information. That was the same thing about sort of being able to access areas of memory. So in the case of Mongoose, if I look at my application, I have something, again, fairly typical, which is I have a schema, and in that schema I have a content buffer. So, a little bit faking it here in a to-do app. Maybe I don't need a buffer, maybe strings are enough. But, for various other cases, if I want binary data, I might want to allow this. So, let's look at how this might be exploited. So if I go back to my to-do application, if I sort of open up a browser, sort of go to the network section, I'm just going to do, by beer. Again, I don't need to remember that before. So I can see that this is a post request for HTTP localhost 3001, it does a get, and sort of somewhere here in the bottom I've got content by beer, right? So I'm going to cheat a little bit and just look at an existing file just for brevity. So I can replicate this sort of same action here using a curl command. Right? I can do a curl to this. I'll request a post. I'll provide content application form encoded. I provide the cookie. So to do this, I do need to export user ID to provide a fresh cookie. I did a little bit of a cheat here to just expose that for me. And here now I can run this command again. And if I do this for buy bread, I go back here, it says buy bread. However, this is Node, right? So in Node we tend to really like JSON. So my Express server, like most Express server, is configured to also support JSON. So I can say application JSON instead. Just sort of change the format here to say content, and then I'll change this to right, if I do this, then I just submitted the same information in a different format, and it works. I just have it right now. Now let's start playing. So I can do this here, and I can say, well, I can also pass 800. If I do 800, it's just a string 800, but I can also pass 800 as a number. Now this time it's passing in through JSON. That JSON will be parsed into an object, and that 800 would not be of type string, but rather of type int. So if I do this, and I go here, I'll start getting some binary information. And if I do this a bunch of times, and I can maybe sort of grow this buffer a little bit, I'll get a bunch of information here. And if I do view source, it's going to be a little bit hard to see this via the all the sort of binary stuff. So actually, instead of sort of looking here, you might see some prototypes and pieces of source code that are sort of looking into to this information, right? It's a little bit easier for me to do maybe a curl on localhost. I guess I still need the user ID. So like this. Curl, this user ID, and then I'll just pipe that into strings. Whoop, what did I forget? So piping that into strings, I see a bunch of strings in here. And each time there's some .result or some .dysfunction. And I can run, and this makes it very, very easy for me to just sort of run a loop in the background that just creates an element, extract whatever strings from it, closes, deletes that element, so no more elements are there. Again, not great, right? This is how sort of private keys get leaked, how secrets get leaked information. All right. Let's sort of clean up our to-do list a little bit here, so it's not as dirty. Just sort of do this. And let me sort of show you one more. And I'd like to sort of stress out that there's sort of maybe two things to understand about these. One is these are vulnerabilities that you might get from your dependencies, but the second is these are vulnerabilities you might have in your code. So just sort of pay attention when you are developing it. So the last one I want to show you is in the MS component. So MS is a popular component. It's a library, very, very simple library, that all it does is it takes a string like 2 hours and converts it into the number of milliseconds. And to do so, and I use it for that remind me in blah, then that uses milliseconds. And to do so, it uses a regular expression. Now, a regular expression has the tendency that if it runs on a really long string, it can take a disproportionate amount of time, an exponential amount of time to actually run on that string. And that's not good. And as a result, that can drive denial of service attack. You can basically take up a ton of time on the server. So let me show that in action again. I'm going to cheat again and look at an existing one here. So just sort of going through the flow here. First of all, I'm just going to do by milk reminds me in 60 minutes. It's going to pipe into a curl. If I go back to my to-do application here, it'll say, well, by milk in 1 hour. However, I can get fancy, right? I can do this, which has sort of this printf 5s 60,000 times. So this is going to create a string with the number 5, the digit 5 repeated 60,000 times in that string, and I'm going to post that. So if I do this, that also finished fairly quickly, because running on a regular expression that matches is much faster than running on one that doesn't match. So let's do one small tweak and say, write A here instead of the S. If I do this, it doesn't return very quick. And what's interesting is that while I do this, if I go around and I click here and I press enter, nothing happens. Any reasons, any ideas why? The event loop is blocked, right? So this one is, it's not specific to Node, but is especially great in Node. Node's scaling model is on asynchronous activity, not on threads. So a typical Node application in production, in large scale, would have a very small number of threads running. So you could try to mitigate it, but the very... So you could drop connection, you could put timeouts, but how quickly do you drop a connection? Do you let it run for 10 seconds? I can very easily hog your connection and just sort of send these requests in sequence. The entire premise of Node works on this notion that every thread or every piece of execution yields. The scaling model works in the notion that you don't run things for a long period of time. So every one of these flaws, every one of these cases where you have an algorithm that takes a long time to run, or you sort of process, I think earlier on we talked about a map that has many items, it's true on the client where you get that prompt that says the script is there. All of those are problematic. Now eventually these actions got invoked, but I could have run this script for a long time. So again, it's something for you to keep in mind. Every time you're running a regular expression, you want to make sure that you contain enough text on it, so the length of the string you're running on it. Okay, so these are just a few examples. I'm not going to show every single vulnerability. There are many vulnerabilities that are in different node modules. Let's talk a little bit about how we can handle this. So to do that, I'm going to use the Snake Wizard. And the wizard does this. This is the second time I'm running it, so I'm running it from clean. What it does is it repeats the test process, and it prompts you into how can you address those issues. Wherever possible, the best way to address a bug is to upgrade to a new version that fixes that bug. So that's true for vulnerabilities, true for security bugs as well. So in this case, you might want to say upgrade Mongoose. This vulnerability was introduced in, it existed in 4.2.4. You need to upgrade to Mongoose 4.3.6. Easy enough. I'm just going to upgrade. I'll do the same for MS. And then sometimes you have cases like this where there are vulnerabilities here. The vulnerabilities are, if I click this link, you'll see the test results for serve static, and you'll see that a bunch of the vulnerabilities found on it are not in actual serve static, but rather in a dependency of serve static. So you pulled serve static, and that in turn pulled in others. So to do that, you can't upgrade send, and you can't upgrade MS. You need to upgrade serve static. So the wizard will kind of navigate the NPM space and tell you which direct upgrade you need to do in order to make that vulnerability go away. And then, last but not least, sometimes you can't upgrade. And when you can't upgrade, because your direct dependency, the actual vulnerabilities, the actual modules with the vulnerabilities almost always have a fix. There's almost always a fixed version. But the problem is you're not using those directly. You're using them via other dependencies. And that chain takes a while to get updated, or sometimes there's a slow project in between, or other reasons, some major upgrades, other reasons to make them not upgrade. So in those cases, you're kind of stuck. You can't just sort of upgrade those. So for those, we've created a bunch of patches. Those patches, and in general, all of our vulnerabilities are stored on GitHub. They're open source. They're on snake/vulndb. And you can go in here. You can see under the data npm folder, you can see different vulnerabilities. Let's look at a recent one, for instance. Hawk had a vulnerability. And what you can see here is you can see some information about the vulnerabilities. They're all posted here, as well as sometimes patches. And we try to create patches for as many of those as possible. We don't have them for all of them. We have them for about 75–80% of the cases. We do accept pull requests. You're welcome to sort of go in and try to sort of append those. And oftentimes it's more of an exercise in retrofitting. So the fix exists on the original module, and you need to sort of backport it to some older version. So here I'm going to choose to patch. Now, two last things before we sort of complete here. This was fine to sort of clean ourselves some vulnerabilities right now, but how do we stay free of these dependent vulnerabilities? So there are two things you can do. First, you can add sneak test to your package.json's test process, and that would make sure that every time you add a module, add a package that has a vulnerability in it, the build would break, the test would fail, and you would take growth and you would take action on it. So Snake Wizard can do that for you to add it to the npm test. If you run your test in a different fashion, you can add it to it. And then lastly, when I patching modifies the local files. So I just fixed the vulnerability on my local files. But if I'm going to package this up now and post it onto npm, even a private npm, and use it later on, I need to make sure I apply those patches again and again. So to do that, I can again use npm's hooks, and I can add sneak protect to the pre-publish stack. It's a bit of a misnomer. It's actually a post-installation hook, as well as a pre-publishing hook in Node. And that will make sure that every time I install this package, I actually patch it. So I'll do yes. The whole process would run here. The patches would be applied. npm would be updated, or the modules of npm, and all will be well. So let me kind of switch back to the slides, and we'll get back to this one in a moment. So here's my ask of you, or my suggestion to you. First of all, worry about, or know about this problem, worry about this problem. It's a real problem, it's a real risk we have. Use Snyk Wizards to fix your current vulnerabilities. Add Snyk Test to your CI process, to your build process, to your test process, to make sure that you're not adding vulnerabilities or adding modules that have vulnerabilities to your system. And make sure that if you've patched anything, you run Snyk Protect every time that happens. And then the last piece is the other way that vulnerabilities can kind of get added to your vulnerability-free system is for new vulnerabilities to get disclosed. But these are, new vulnerabilities is not the right name. These are new disclosures of vulnerabilities. The vulnerabilities are old. The vulnerabilities are in old code, and they've been recently disclosed. So you want to make sure you're on top of that. And to do that, you can run Snyk Monitor, and the wizard also does this at the end, which takes a snapshot of your dependencies. And then we can send you an email. We can alert you every time there's a new vulnerability that gets disclosed that affects your specific dependencies. So if I go back to my monitor over here, the wizard took a snapshot of my dependencies, and I can go back. It would actually bucket them into sort of a history. I can go back and see all the different snapshots that I've taken for this application. But really what's more interesting is the fact that I've captured the dependency tree. So now that I've captured the dependency tree, I can actually know which dependencies you're using and alert you to new vulnerabilities. So to make sure that we have the freshest understanding, the kind of the most updated understanding of which dependencies you have, try to integrate this notion of the monitor into your flow, right, into your deployment process, continuous deployment to others, and then respond to those alerts when it happens. That's it for me. Thank you. Any questions?
Do you only ever do that when you have a fix? Like, so the disclosure and you have a fix?
Right. So the question is whether, when I add this, like adding this to the CI process, what happens if I don't have a fix, if there's no patch? So what I kind of glossed over it, but you can actually, the intent is for you to add it to the CI process, period. If there's a vulnerability that you have neither an update nor a fix, you can choose to ignore, and that would sort of snooze the vulnerability. By default, it ignores it for 30 days. You can add it to the policy file when it gets generated. But yeah, you don't know when will there be a fix or not. If you took a snapshot and there is a new remediation path that didn't exist before, so there wasn't a patch and now there is one, or there wasn't an upgrade and now there is one, we'll send you an email on a weekly basis. You'll get emails with new remediation paths. Yeah.
What's the difference between this and package stores? You just focused on JS?
Mr. Mid, I don't know package storm.
It's an exploit.
So this is, we don't exploit mechanism. Yeah, so I don't know package storm. There's Metasploit. There's many other sort of exploit tools. This is not a testing tool. This is what we do is we inventory your components. We don't do the static analysis on the code. We inventory the components you have. We match them up against this vulnerability database that we maintain, and we create the patches for you to be able to fix the cases where you can't upgrade.
Okay, I guess what I'm asking is the inventory database on the back end. Is that your own creation, or are you leveraging something else?
This is our database that we maintain. In the world of vulnerabilities, there's the common vulnerability enumeration, the CVE database, which is great, but for nodes doesn't quite happen. Most of these vulnerabilities don't have CVEs. Sometimes they're filed, sometimes they're not filed. So we maintain this database. We maintain it from many sources. I'll look at packet storm, but we look at the Node Security Project, which is a good project that we are in good relationship with. They focus on finding issues. They have most of these. We look at GitHub issues that get opened. We look at many of those. And we focus them all into this project.
Right.
Yeah.
This is open source. How do you feed your children?
How do we feed our children? So the intent, the test process, the protect process, all of this is meant to remain free, will remain free. The monitor process, the ability to get alerts, to sort of act on them in real time, at some point will turn into a freedom. So right now we're spending decent money, but at some point in time, some aspect of that monitoring, we're not entirely sure where that line was drawn, will happen. But test and protect, not only are they free, they're intended to remain free. The goal is that everybody here writing an open source project as well and posting those would have the test and protect process from it, and they don't require authentication, they don't require registration. They're sort of meant to sort of help embed security into this world. Yeah.
I felt slight sugar when you said you were patching stuff and install, which basically means if I download an npm package and it's a post install thing, I'm running code that you haven't tested, that I haven't tested, or that the producer of that code hasn't actually tested. I mean, there seems to be a little bit of a workflow thing there about.
Right. So the question is basically about the fear of the patches. What's the likelihood of these patches breaking code? It's a concern. So clearly it's a concern. We don't take it lightly. There's no perfect solution. You're sort of stuck, right? You either accept the vulnerability. You can't upgrade.
Yeah.
If you can upgrade, you should upgrade.
Yeah.
But you sort of need to accept that those sort of two evils. The good news is, first of all, these patches tend to be very concise. They're based on the original fix by the author, and they tend to be pretty small. They're all open, so you can also look at them and make that judgment call yourself to say, how risky does it look to apply. And that sort of reduces the risk. In addition, we do have a testing battery, so as soon as we apply it, we would run the packages test, and we'd also go another tier around it. So a set of packages that use this package and will run their test. None of that is perfect. We have all sorts of ideas about how to improve that sort of in an automatic basis.
You publish those patch test results, do you absolutely blue tick?
We don't publish them right now. We talk mostly because that code is ugly. Like we need to like if you just publish it but it's not readable, it's no good. So we're trying to sort of think about that. The intent is that battery would become public, yeah. So that's sort of how we operate there. We contributed a couple of those back into the streams, but that's another chunk of work. Just there's a limit at some point to how much we can do. Yeah.
Because your patch may be a valid test, so the existing test suite for the thing you're patching exposes vulnerability. And maybe automatically open that as a pull request to the original project.
Yeah. So there's a lot of
What to do?
yeah. So the question is whether our patches basically how can we embed into the original the original module that had that vulnerability both in the test phase but also maybe in the patch of the solution because we backported it to previous versions. So we haven't thought of creating tests. That's an interesting proposition.
You did run that as part of the patch process to prove that you fixed the vulnerability.
The vulnerability existed before or not. So I guess in the good cases then, because these vulnerabilities tend to be fixed by, in the very latest version, very latest stream, tend to be fixed by the module author. In many of these cases they come with a test, so they would have some tests for that component. So we don't backport those tests further back, just sort of, we haven't done that yet, so it's a good idea. In terms of contributing those as test requests to the original module, it's just another chunk of work. We have no problem. We've done it for Hawk for request. It's just a piece of effort that at some point we need to sort of draw a line because we're not feeding our children.
So part of the problem is that if there are some major version changes, and nobody backports stuff to old versions, but people are still depending on the previous version of the
yeah, precisely. This is so upgrades are problematic, especially across major versions. And I guess in the popular request of Hawk is just the most recent example I have in mind. Hawk 4X didn't support Node 4 and earlier, so request, which is a very popular module, was stuck with Hawk 3, which didn't have the fix. We converted that back, and that got fixed. We kind of cherry pick those just for good. So anybody's welcome to take those patches and backward them as well. Yeah, so I'll go to the other side. Yeah.
The wizard thing for applying the patches would be great. But if you went to Automator as part of the CI itself, is like a minus patch yes option or something to
right. Yeah.
do that?
So I guess the question is more about like the wizard is interactive. What do you do in an automated environment of it? So the wizard is actually just a shell above 3 commands: sneak test, sneak protect, and sneak monitor. When you ran through the wizard, it actually generated this .sneak file, which has the instructions. For the upgrades, they went, if I do a git diff, I'll see that the package JSON file was actually modified. You can see the hooks here, and you can also see the packages that I've modified. And so the upgrades go into package JSON. The ignore and patch decisions go into a .sneak file, and sneak test and sneak protect would follow those instructions. So you don't need to do. And sneak test and sneak protect don't require authorization, but monitor, because we need to store it for you, does require authorization. So the wizard, I was already authenticated here, but the wizard does prompt you for authentication. We authenticate with GitHub. We don't have access. We don't ask for access for repositories. We just want to spare you another user. And again, that's doable in the API. Just do sneak. Anyways, like it's only logging. Sneak auth API key. Other questions? Yep.
This is a little bit cynical, and I apologize in advance. Can you sneak
You can snick the snick code base, yeah. And you find, I think today we don't have any of those. We had one that was patched. It's a good example to say that you can actually do, so you can choose any package. Good. Okay. Thank you very much. Enjoy. Do send feedback. We've got on Twitter. We're on GitHub. We're on all of these paths, and we love feedback. So let us know what you loved, what you liked. Thank you. I got some requests. So we have some of these magic wands in it. They open up like this. They do roll back up. So if you got one of those and you think you're now stuck, you can actually roll it back up. And they do roll. It takes a moment, and then you roll those back. So they're on their own.
Okay.